Howdy class. We're going to go through some of the fundamentals today for Python programming, some of the core features. We're also going to talk through Jupyter notebooks and look at those tips and tricks. If you haven't yet looked at last week's module, I strongly encourage you to look at both of those videos about getting started with Notebook and then tips and tricks for Notebook. One of the tips and tricks that you'll need to know is, first of all, when Jupyter Notebook opens, it's going to be in the browser. It's not a standalone application. It's just in your browser. And this is what you get. Here's my COMSC-140 folder, and I would encourage you to put all of your stuff into a COMSC-140 folder so everything's neatly arranged and easily accessible. From here, you can just click on the notebook to open it up. And here it is. Now, to rename a notebook, you just simply click on the title bar here and rename it. I'll call mine Sandbox again, just for the heck of it. Now, after you've done your coding here, the most important thing is how to quit. Now, don't just close the browser tab, because that leaves the instance actually running still. You want to go here to File and then select Close and Halt. And that will gracefully shut this down so that it's not running. If you happen to open up a notebook and then just shut it down like this, well, you'll see here down in the Jupyter main listing here that this sandbox.ipynb has got this green icon now. And the green icon means that this is still running and you need to shut it down. It's still occupying cycles. So to shut it down, you can either open it back up and then gracefully shut it down, or you can click that little checkbox there next to it and click shut down here as well. The Jupyter notebook interface here lets you do a couple of file operation types of things when you click a certain file. You can go up here and hear all of your options. You can delete it, rename it, move it, download, all of that stuff. So you do get some file operations. So I'm going to open it back up again, and this time gracefully shut it down, close and halt. The next thing to remember is now this is your core Jupyter screen here. This is the primary interface. If you're ready to quit Jupyter, same thing. Do not just shut down the tab or shut down your browser. Instead, you need to press this log out button up here. The log out button will then successfully log you out, shut down the server, and then you're ready to go. So what I'm going to do now is, now that I've shut it down, completely close that browser tab, and I'm using Chrome here. I'm going to go back to Anaconda Navigator, and I'm going to reopen Jupyter Notebooks. I'm going to go back into my COMSC-140 folder, and here we are. Now you can also click over here on last modified, and it'll sort by the last modification date. You can sort up or down. So I'm going to do the new one here, and let's go back into the sandbox. Okay, so just remember those core kind of navigational and fundamental things about Jupyter notebooks. Bottom line, never just shut down the tab or never shut down the browser. All right, well, let's get started. You know, we're gonna, your assignment this week is to download the Jupyter notebook and then just simply amend it. And I'll go over that in a little bit. You'll see the assignment, but I want to first just kind of go over some of these core foundational things. Let's see, the first thing is printing in Python. We're going to use the print statement to print things. And what can we print? Well, we can print any variable. We can print any literal that we want, and a literal is something that we literally type in. We can type, or we can print a string, and a whole bunch of other stuff. But we'll start with that easy stuff to start. Let's start with a string to just say the word hello. This is common in hello world programs. And for print, we just use the print command, and then we type in hello. Now the string hello needs to be encapsulated in the double quote marks. You can also use single quote marks just fine. I'll go to single here to kind of demonstrate that. And now we've got a valid Python statement. Now inside Jupyter Notebook, there's going to be three ways to run this cell, okay? One is you can press this run button right here. Just press it and it runs that cell, it runs the code in that cell, and then here is the output, hello, right there. So that's way number one. Let's change this string now to hello there. And the second way to run it is to press Command Enter, or on a Mac or on Windows, Control Enter. So there I just hit, I'm on a Mac right now, I hit Command Return and it ran that cell. There's a couple of other ways to run. If you go up here to cell, you can just simply click run cells and it will run everything. You can also click run all. And then as you get going, you can see, well, I don't need the stuff above me run again, but maybe I just want this cell and everything below it to run again. And you can do things like that too. Run all below. It's going to run this cell and everything below it. Run all above is going to run this cell and everything above it, etc. So that's the easy thing to accomplish here. Quick win is just the simple print statement. Now in Python, we will get progressively more complex in our print statement operations. We will add more variables, more elements to print out. We will add output formatting to really control and drive how we want our output to look. But for right now, this string is just fine for us. Now, the next thing to know about programming, and we learned this a little bit in chapter 1, and you'll see it in chapter 2, is comments. Comments in Python start with the pound sign, and a line of comments is never executed. The interpreter just passes by that line. So here I've written, this is a comment line. It's preceded by the pound sign. I'm going to run it. And we can see that there was no error here. If I forget to take the pound sign out and try and run this, well, you'll see that we'll get some type of a syntax error here saying, oh, something's wrong. So I'll put the pound sign back in, and that shows that this is a valid comment. You can do comments either on that line. You can also do a comment at the end of a line like this. And when you run that, you get the same result. And the interpreter is just going to ignore the whole rest of the line there if you do start a comment after a valid Python statement like this print statement. So that's comments. We will use comments quite frequently. I'll ask you to liberally comment your code as we go on, and you'll get the hang of commenting pretty rapidly. Oops. Okay, let's talk about variables now in Python. Variables are easy. To create a variable, we just simply declare it and give it a value, and it is that simple. If any of you are C++ or Java programmers also, and now you're just exploring Python, you'll note that this is significantly easier in Python compared to other programming languages. So if we want to make a variable, let's call it age, we just simply type age equals, and then we give it a number. So this statement here does a number of things all together. It first creates the variable named age, and then it assigns the value 38 to that variable. So now if we were to print out age, it would print out 38. So that's the way variables work in computer science, very similar to variables anywhere else that you've used them, especially in previous math experiences and algebra and trig. Same concept for variables. Now in Jupyter Notebook, it's important to know that every cell doesn't need to be a complete program, okay? As soon as you enter one particular instruction into the Jupyter Notebook's memory, well, then it's accessible. Okay, it's accessible as long as that's that Jupyter Notebook is open. So here I've got age equals 38. I'm going to just run that. Nothing's going to happen because I didn't tell it to print out anything. I'm just saying declare a variable age, put the value 38 in it, and then we're good. Well, let's manipulate that a little bit now. In Jupyter Notebook, you can press this plus sign, and that will create another cell beneath the one that you're doing. And I'm going to do a whole bunch of these. Alternately, you can also hit B to add a cell. And then here's another thing about Jupyter Notebooks. You'll slowly kind of get the hang of this, but a cell can either have code in it or can just have text in it. And if you want to change this cell to a non-calculating, non-code cell and just have something that's got text in it, well, then you can convert the type of the cell here to Markdown. And then you can see here, okay, there's nothing to run. We no longer get this in8 thing. And now we can just simply type in things that we want to put into the Jupyter Notebook, such as, this is part 1. Maybe I give you an assignment saying, okay, here's part 1, part 2, part 3, and then you can kind of narrate as that goes. Now you actually do need to run the cell and it will change it to what looks like normal print. And now that we've done that, if we did this, if we print age, we'll see that we'll get that same age equals 38. Now in this cell right here that's highlighted, again, age is accessible because up here in this previous cell is where we had declared the variable and assigned it a value. So you won't need to do this again. Put age equals 38 because it's already been declared. If you do that, it's just going to kind of overwrite that variable and assign a new value to it. All right, so that's just starting with how to start working with variables in Python. Now, variables can have different data types. The main ones are it's either going to be some kind of a string, which means it's a bunch of characters put together in some type of a sentence, or maybe some output. Up here in this cell that we had earlier, the string that we printed is the string that's consisting of those 11 characters, HELLO space THERE. So that collection of characters put together and then bounded by either single quotes or double quotes, that comprises a string in Python. There's also 2 types of numbers, and those are integers and floats. Integers are whole numbers and will never display a decimal place. And a floating point number is a number that has got some decimal component. The beautiful thing about Python is that you can enjoy the processor assigning the variable of the correct data type just based on what was assigned to it. So here in this line here, there we go. In this line here where I'm circling, age is an integer variable. And why is that? Well, it's because we had given it an integer assignment. We could change this to a floating point variable just by giving it a floating point number, or even, we could assign it to a string. And our code would compile there. I'm running that cell and it'll compile. You can actually go and reassign a variable's data type. So here, age was initially declared as a string, but then look down here in this cell where I've got highlighted. Here I redefine age as an integer, and the interpreter is smart enough to know that it's now an integer. It's going to change the data type of that variable, and we can then use it, treat it as an integer and use it as an integer. We'll get into some more data types as the course goes on. There's also some Boolean data types that are just true and false, and then a few more advanced ones that we'll look at later. let's see, a literal. Let's talk about that. You'll hear me say, well, just use an integer literal, or what was the string literal? And in this statement, or in this cell right here, 10, the 38 is an integer literal. It's called that because I'm literally typing in the characters 38 to assign it to age. A string literal will have, of course, the whole sentence or the whole string bounded by the single or double quotes, and that would be a string literal. We call it a literal because it's not a calculated value. It's just simply something that we've kind of fat fingered typed in there. Now, we can have our variables declared as part of a math expression even. Let's say we want to say age equals 38 plus 5, and then when we run this, we get a 43 here for the output. So you can see that it has gotten that math operation finished, and then it assigned it to age. We can also say, all right, well, someone else's age can be based on another variable. Like that. Here I've got a variable called age2 now, and I'm going to take whatever age is and add 10 to it. So age up here in this previous cell was currently 43, and we're adding 10, and now that's 53. So a variable can be declared either with a literal assignment, or we can have some type of a math operation involving other literals, or we could have some type of a math operation that is involving other variables. Later in the semester, we will have return values from functions that can be assigned, but we'll get to that. So that's this idea of a literal, okay? Let's talk next about how to get keyboard input from the user. Let's say now, instead of all this, we want to actually ask the user, okay, let us try and obtain the age from the user. So the way we do that is with a special input statement like this. First, we'll call it age. I'll do single quotes. And then let's run this. When we do run it, we see that we get this extra dialog box here and a little slot in the console, so almost to enter some data. So I will put my real age here, 38, and now that's entered into memory. So if we were to print age here, you guessed it, we would get 38 because the variable in memory was most recently assigned the value of 38. So that's what we're going to get here in this cell 16. Even though further on up here, we had assigned age to other variables and things, that's redefined now, and the processor is always going to take the latest assignment. Now, here's a problem. What if I wanted to print age plus 10? Well, here's a problem with that. The problem is that age plus 10 isn't resolving. You know, you can do a math expression within a print statement nice and easily, just like that, but it's not resolving. And the problem is that up here in line 15 here, anytime you get input from the keyboard or from the user, it's always going to be entered as a string. And a string is not a number. And that means that we cannot use it as though it were a number, okay? That's why here we're getting an error, because age is a string variable and 10 is an integer literal, and you can't add those together. You can't add a string and an int. You've got to add together an integer and an integer, or even a float and an integer, but you can't do a math operation with a string. So we have to convert that to an integer. And all we do is we put the word int in front of the input statement, and then we put another set of parentheses around it like that. And then when we run this, we'll get please enter your age again, and I'll enter my real age, 38. And now that that's properly, age is properly declared as an integer variable, if we run this, then we will get the correct math expression here because age has been converted to an integer. So you'll want to do that. Oops. There we go. Let me copy this. You can do that. You can also make it a float by changing int to a float. So if I were to run this, here's our age. I'll put my real age. And then I'm getting the prompt to enter my age again because of the second line. And this time I'm able to put, a decimal number there. And it will accept that. So that's getting input from the user. Now, the big thing to remember is to convert that string to an integer or a float right when it's being entered. A beginner coder mistake is commonly you forget to convert it to an integer or a float. As a result, you're just dealing with strings. So to make sure not to forget that in your coding. All right, well, next, let's talk about various calculations and things in Python. And I'm going to shift over and go over to my my iPad that I use as a whiteboard and start drawing some things on there for you. Okay, let's talk about Python calculations now. First, the operators. A math operator is what we call the addition, subtraction, multiplication, and division operators. The syntax for those are pretty self-explanatory, except for the asterisk for multiplication. We don't use an X in Python to denote multiplication. We will denote it with an asterisk always. And that's common throughout the various high-level programming languages. So we'll clearly use a plus sign for addition, and that would be the addition operator. We've got the subtraction operator, multiplication, and then division. And those will function exactly like we might expect. There's a few more, and we will use these extensively. And let me just list those out, really right now. Let's see. One is the exponent operator, which is asterisk asterisk, raises something to the power of something else. There's a remainder operator, remainder. That is the percent sign. And we'll be using that a lot to calculate, well, what the remainder is after a division operation. There's also integer division with slash slash that we can use to just get the integer component of a certain division operation. So if we were to want to take two variables and say add them together, let's say the variables are A and B, then our code would really just be A plus B. If we were to print this, we could do print A plus B. Remember, if you just type in this A plus B, Python will recognize it and will calculate a sum, but we're not doing anything with it. We have to do something with it. And the doing something with it is either we're going to print it or maybe we assign it to another variable. So this code here will print out that operation. Just like we saw a little earlier, we can always assign it to another variable. So here's C equals A plus B. And if we were just to print out C here, we would get the same results as the print A plus B. Multiplication, quite easy. A times B, division, A divided by B, power, an exponent, A raised to the power of B. And you can get the idea here. We'll be mixing and matching these things all semester long. Now, we follow a certain precedence of operations in Python, just like the other computer science programming languages. And then this is very common too to what we learned in previous math experiences as far as the hierarchy or the precedence of operators. And we follow kind of the same generic rules that we were all kind of grew up with math. The first thing that'll happen is anything that's in a set of parentheses will get reduced first. Then from there, any multiplication or division operation is going to take precedence then over a math or subtraction. I'll add to this here that the exponent is included in that upper level. So if we have a statement like this, A plus B times C, the interpreter, the Python interpreter, there's no compiler in Python, it's just all interpreter. It is first going to evaluate B times C, and that's because multiplication here has a higher precedent than addition, as we saw here on the hierarchy. Here's level 1, level 2, level 3. So this will get resolved first, and then that gets added to A as the second step. Now you can always force operations. Here we've got the same A plus B times C, but let's say that we wanted actually the A plus B to be evaluated first and reduced. Well, then we can just bound those with parentheses, and then according to our precedence of operators there, we will have that reduced first, and that result then gets multiplied by C. So fairly straightforward precedence of operators. Make sure that you force the earlier operations that you want with a set of parentheses. Let's see, for exponents, we would simply just say, A raised to the power of B, and I'll show a couple of examples about this. The remainder operator is the percent sign, and that gives us the remainder. Let's say that we've got A equals 17, B equals 5. And if we were to divide these, it'd be 17 divided by 5, right? A divided by B, 17 divided by 5. And if we were to reduce this to fractional format, we would get 3 2/5. Well, what the remainder operator is going to do for us is return this number right here. It's going to give us the remainder. Similarly, if we were to ask to use the integer division operator, we would get this, just the whole number component. So if we use integer division, that's what we would get. If we use the remainder operator, which is the percent sign, that's what we would get. And later you'll see in the course, the remainder operator, it's also called modulus, and you'll hear me call it both of those things. The modulus operator is what we'll use as our primary weapon of choice if we're trying to figure out whether a number is odd or even. Here's how we can do that. We can say, okay, well, I can just look at a number as a human and see if it's odd or even. But if we ask a computer to decide if it's odd or even, then it will have to figure that out. So let's say we have a number 5. Well, we know looking at this that it's odd, but the computer doesn't. But what we can do is tell it, okay, if we were to take the number 5 and mod it by 2, and modding means use the modulus operator, use the remainder operator. By 2, we would get 2 1/2, correct? Well, if we use the remainder operator, it's going to return this 1 right here because we're using the modulus operator. And that's going to be our key here. So if this is ever a 1, if 5 modulus 2 equals 1, well, then we know it's odd. Otherwise, if we have an even number and we mod it by 2, 4 divided by 2 is going to be 4 divided by 2 equals 2 and 0 halves. And that means that the remainder is 0. So if the remainder is 0, then we know that it's going to be an even number. So that's an example of using this modulus or remainder operator, and we'll get into a lot more of that as the time goes on. Now we can just about, using a good combination of parentheses and very carefully crafting our statements, we can take any kind of a math formula. Let's say let's try a better one. This will be a true math formula. A times B over 1 minus C plus D. Well, here is something that looks kind of daunting, but how would we convert this then to a Python statement? Well, quite easy. This is just a numerator divided by a denominator. So in Python, we would then just have some type of numerator code here divided by some type of denominator code here. So we'll put the numerator code here, denominator code here, and we'll kind of bust up the problem into smaller components. Well, the numerator is just A times B, so that's just going to be A times B. The denominator is literally 1 minus the quantity C plus D, and we put those in parentheses, C plus D, to make sure that it's evaluated properly in the right order. And then this statement here is going to be a valid Python statement that we could then assign to some variable. Result equals that. Now we want to make sure that we use our parentheses to do the denominator and the numerator, because if we don't, we would have this expression, A times B divided by C, and then there'd be some ambiguity here. No one would know what to do here until we get the 1 minus all of that. So parentheses are going to really drive this, this calculating behavior, okay? We're back in Jupyter Notebook here, and I'm going to just do some kind of operational randomness here and look through what we just covered with calculations and do a couple of really quick and light examples here. Let's say we wanted to do the exponent thing. I'm going to do here print 4 to the power of 3. And there's the exponent operator in action giving us 64. Spaces aren't important. You can take out those spaces and it'll still, the interpreter will still process that, that line. We could take that and assign it to a variable like this, result equals 4 raised to the power of 3. And then if we were to print result, we'd get the same answer of 64 there. Here we assigned it to a variable because perhaps later in our code we need that variable. We might need it for some type of an additional operation or just for reference. So let's see, that was power. Let's look at that remainder again. My question here is 7 odd or even? And using that modulus operator tells us that, well, it's odd if the modulus is 1, it's even if the modulus is 0. So if we did print 7 modded by 2, we get a 1 there, and that tells us that it in fact is an odd number. And that's because 2 does not divide evenly into 7. It divides 3 times with a remainder of 1, and that's the 1 that we see there. That's the remainder operator. If we were to say change this to an 8 and see what happens there, well, 2 does divide into 8 evenly, so the modulus is 0. And oops, I didn't need that. Let me convert that back to code here. let's see what else to talk about. There's that integer division component also that gives us just the whole number fraction. So if we were to print here 7 and then use the integer division operator, this will give us 3 because 2 divides into 7 3 times, 2, 4, 6. So 3 times. There's some remainder, but we don't care about the remainder. All we care about is the whole number component of that division operation. So that's where we get the 3 there. You can see that we could really get advanced here. If we wanted to output 7 divided by 2 in fractional form. So let's try that. We'll print first. We know that the first thing that we'll need to print out is the integer division or the whole number component. So let's print that first, 7 by modded by 2, I'm sorry, integer division 2. Then I'll put a comma because in a print statement, you can output whatever you want, including multiple elements or items. Just separate them by commas. So let's see, here we got that. I want to print out a space, so I'm going to literally print out the space character and then a comma. Then we're ready for the remainder. So let's do 7 modded by 2. And I think for readability, I'm going to take these spaces out here just so it is a little more readable. So we'll get 7 mod 2 there, and that's going to give us the 1. Then we will want to print a /. And then we can also print out the literal under it like that, divided by 2. So let's run this and we get that answer there, 3 1/2 in fractional form. And again, we did that using a combination of the modulus operator and the integer division operator. All right, gang, I think that is going to be about it for this introductory. Let's look at some of your, let's look at the assignment and just make sure that we go over that. So hang on one second, I'll go back to Canvas now. Oh, I guess I've been recording. All right, here is our lab for this week. And it's Lab 2.1's Foundations. We're going to look at input, output variables, and calculations. I implore you, please read the book first. Otherwise, the lab just won't make sense. Here's a little section on comments, and I've got a cell for you to experiment with comments. The next little section is on variables. Make sure to run this cell. That's why I put make sure to run this cell as a comment. And that's just so we have that as a reference for subsequent cells. And then here are just kind of a few guided, small things to think about and to write. You'll see things like now code, you code now, and those are where you have to come up with a little script, a little Python script now based on what we just learned, and put it in this cell. For each of these, I try and give an example of output. So here in this cell, I want you to try and code it so that your output matches that output. Here's the section on keyboard input that we just mentioned and a few opportunities for you to try. And then the rest of the lab is on just starting with calculations. So I'm giving you a couple of good assignments here. You code now number 2 is to just simply get 3 integers from the user. And add them together, and output the sum. Nice and simple. The next one here is to actually have a calculation for sales tax. We have the user enter an item price, and we can get that as a float from the user. And then from there, calculate the sales tax and the total amount. In this fourth little segment here, we'll do a little miles per gallon calculator and have the user enter how many miles they drove and then how many gallons of gas they used. And then you can output both of those and calculate miles per gallon. And that's just simple miles divided by gallon. And then we have this last one here to calculate a retail markup. Typically, a store is going to buy an item from its distributor or its wholesaler, and the retailer will buy that at a retail price, which is down here. The retailer will then add the markup to it, and that's how the store earns their profit. So this script is going to have you enter a wholesale price and then a markup percentage, like 10, 15, 20%, whatever you want to do. Make sure that you follow this little hint here that I've got highlighted, because when you enter 20 as a percent, if the user enters 20, well, we have to divide that by 100 when we use it in math operations. Otherwise, we're going to get wildly out of scope numbers. So make sure that you divide that by 100 when you use it to determine what the markup amount was. So pretty straightforward opening lab here. Shouldn't be that much trouble for you. And if you have any questions about the lab or about really anything that we're doing, please pop your question into the Module 2 discussion board. That way I can answer your question and everybody can see it. Please don't email me with questions. Instead, get into the habit of putting those on the discussion board. That way all of the students can derive the benefit of the answer and seeing the conversation and the answer rather than just one student by email. Okay, gang, good luck. Drop in during live Q&A, please. If you've got questions or if you just want to say hi because you're bored. It'd be great to see you. And then I'll see you all hopefully Wednesday or Sunday, and then if not next week. All right, take care, everybody.